Yeah, so you can click.
Okay, good evening, everyone. Nice to meet you. Nice to talk to you. My name is Peter. I will solve with you some questions, but it doesn't mean like I know all the answers. You might know the answers better, but I'll solve with you the questions that I can solve. Yes, I am Peter and I am from Zambia, studying here. So the first question, I don't know if you have seen these questions before. Yeah, of course you saw the questions. I don't know if you solved this. You went through this question. For the first question, how many of you solved it, and what did you find? Just if you tried to solve, you can just say, okay, me, I tried and I found this and that. Yeah, you can tell us. You can tell me what the answer is, then I will proceed. If you try to solve. There's some people wants to come in. Where should I go here? That was I think me from there. Yeah. Yes. Did anyone try to solve? How can I see like if there are people writing messages?
Yeah, two people want to come in. Just accept, and then you can check from here, but they have to see also the screen. So
There's not the screen.
yeah, this one is being seen. You can control from here. Okay.
Yep. Yeah, I can. But feedback.
Feedback messages. Like
Yeah. Yeah. What is it? I can't see. I can't see.
No, that was the previous answer.
Because I want to know if someone tried to solve question 1.
No, they cannot write. You are the one presenting.
They can't write, but since they had this paper, I just want to know if someone solved it.
Okay.
So yeah, I asked, did anyone solve question 1? If no one solved, then I will solve it, but I don't have a camera. I'll solve it and show you. Yeah, but it's a very simple question, which you should be able to solve in a minute. So apart from question 1, did you check all the questions? I mean, did you go through the second question, the third question? So question 1 is we have fractions. Yeah, we have fractions on the numerator and also on the denominator. So the first thing is to simplify these fractions to write. We have first of all we have like 1 minus half plus 1 over 3, and then we also have 2 over 3 times 3 over times 5 over 6 minus half. So here on the bottom we know that 2 can go into 6. Okay, so yeah, 2 can go into 6. So we have about we have 3. So on the bottom we have 5 over 9 minus half. Okay, that's the first step. And on top we also have yeah, we have 1 plus 1 over 3. 1 plus 1 plus 1 over 3 is, the common denominator is 3, and then we have 3 plus 1. So we have 4 over 3, which is, and then 4 over 3 minus half. So we have, what's this? 6 on the bottom, and 3 into 6 is 2. Then we have 8 minus, then 2 into 6 is 3. So we have 5 over 6. 5 over 6 on top, 5 over 6. And then here what we have is, what's this? 18, then 10, then that is 9, 1 of 18. So what we have is, on top we are going to have 5 over 6. Okay. Someone has. No, I've not finished answering. I haven't finished answering. So we have 5 over 6 over 1 over 18, which is 5 over 6 divided by 1 over 18. And this is 4 over 6 multiplied by 18. And that's 3. So the answer should be 15. Okay. The way I wrote it, I don't know how to. So the first step is to simplify these fractions, both on the numerator and on the denominator. So we have 1 minus 1 over 2 plus 1 over 3. So we follow those rules that, first of all, we do the operation with positive numbers. So we cannot say 1 minus half. We have to add 1 plus 1 over 3, and then we subtract half. And then on the bottom here, we have to simplify. We have 2 over 3 times 5 over 6. So how do we simplify? 2 can go into 6, and this is 3. So on the bottom, we have 3 times 3, and it's going to give us 9. So 5 over 9 minus half. And then we simplify from there. I mean, I didn't write it. I was just writing it roughly. Like the first thing is I did was, on top here, how can I say? On top here is 1 minus half plus 1 over 3, then 2 over 3, and 5 over 6. So I just, 2 can go into 6 3 times. So you have 3 times 3, which is 9. Okay. So this is the first step, and I came here, So I have 5 over 6, and then I have 5 over 9 minus half after simplifications. So when you simplify this one, you are going to have 10 minus, because you're going to get the common denominator of 18. So you have 10 minus 9, which is 1 over 18. Okay. So from this step, I came here, 5 over 6, somewhere here. 5 over 6 divided by 1 over 18. Then this is just simple simplification. 5 over 6 divided by 1 over 18. And then this means that 5 over 6 multiplied by 18, the opposite of this one, which is 1 over 18, the reciprocal. So you have 5 over 6 times 18, which is 6 into 18 is 3, and the answer is 15. Okay. So the challenge is writing. Yeah. I don't know. Someone has a question, I think, or where should I? question, there's a message. I can proceed, but there's a message. No, okay. So the answer is C. It's 15 for the first one. So, like I said, this is what I did. This is the rough work of what I did. Yeah. I don't know. I'll take a picture of it. So now, for the second question, you have 50 squared multiplied by 0.01 minus 0.001 over 225 is what? So 50 squared means just 50 multiplied by 50. Yes, 50 multiplied by 50. And then you have 225. So what should come into your mind is there is a number which goes both into 225 and also goes into 50. And this number is 25. The 25 squared is 200 and is it what? 25 and 225. That's not squared. Yes, there's a number which is going to go into 25 and it's also going to go into 50. So what number is that? Yeah, I think it's 25, yes. But how many times is 25 going into 225? Is that like a message? So the first step is to write 50, like multiplied by 50. Then here we also have multiplication of 0.01 minus 0.001. Let's say 225. Okay, let me start with a small number. I know that 5 is going to go into 25. 225. 5 into 22 is 5 into 22 is 4. Remainder 2, and 5 into 25 is 5, so 45. Okay, so and 5 goes into 50 10 times. Again, 5 goes into 45. So yeah, 45. 5 goes into 45, that is 9. And 5 goes into 10, 2. Okay, what we have here now is 100 on top times 0.001 is the same as 100, 1 over 100. And then 0.001 also it's the same as 1 over, I think, 1000. And so here we have 9, which is remaining here. The other thing is now we can simplify. We can simplify this this expression. Can simplify it. 1 over 100 minus 1 over 1. Actually, I didn't need to do that. Yeah, I'm just complicating things. I would have gone direct by just saying, let me not confuse you. I would just say, here we have 100, then times, so 0.01 minus 0.001. So we have 0 here. So when we subtract this one, we have 9. Yeah, because 0, yeah, we have 9 here, and then we have 0 here. So we have about 0.09. So we have 0.09 on top here, 0.09, okay, over 9. So since this is we have 100 here, there's a rule with multiplying with the what we call them, the multiples of 10. So we just remove the decimal places. So since we have two zeros, we are going to remove these two decimal places. So what are we going to have? We are going to have, if we remove these two decimal places, we are going to have 0.9 over 9. And what is 0.9? 0.9 is 9 over 10 divided by 9. Okay. Divide by 9. Yeah, 9 over 10. Yes, 9 over 10 divided by 9. And that is, what is this? This is 9 over 10 multiplied by 1 over 9. So this one cancels. So this is 1 over 10. And 1 over 10 is 0.1. So the answer should be B, which is 0.1. Okay, this one was unnecessary. This part, this is unnecessary. So what I did, I mean, it's so difficult. What I did is, squared, you can see what I did. Yeah, where is the camera here? This is where the camera is. So 50 squared times 0.00, 50 squared times 0.01 minus 0.001 divided by 225. The first thing I did is, I know that 50 squared is 50 times 50. So I separated it. Okay, 50 times 50. I'm sure you are able to see that if you can see. And then I know that there is a number which can go both into 50 and into 225, which is 5. Okay, so I simplified using 5. So 5 goes into 50, that is 10 times, and then in 225 it goes there for 45 times. And then I simplify again. 5 goes into 45, and it goes into 10. So we have, you know, you can see how I simplify it. 5 goes into 45 9 times, then it goes into 10 2 times. And then 2 times 50 is 100. So I jump to this stage, you know, 100 multiplied by 0.01 minus 0.001. Okay, so 0.01 minus 0.001 is going to give us 0.009. Okay, so what I have here is 100 times 0.009 over the 9 which remained there. So from here, what you just need to do is the simplification. Okay, this is the rule of multiplying with the bases. Okay, what do we say? The multiples of 10. We just remove the decimals. We have 2 zeros, so we remove 2 zeros here. So we are going to remain with 0.9. 0.9 over 9, and this is just 0.9 is 9 over 10 divided by 9, which is 9 over 10 multiplied by the opposite of 9, okay, which is 1 over 9. That's what I did there. So the answer should be B, which is 0.1. Okay. Feedback. Do you hear what I did? Of course, it's simple. This one is simple, yeah.
Yeah.
Nothing difficult, nothing complicated. And the other one is what's that?
So in that question 2, must we start simplifying now from the least value? Can't we just use like 25 because it's still going to give the same answer than to start from the least value? Don't you think it
No,
will take more time?
you can start from 25 as long as you simplify it. Yeah, you can use 25.
Okay.
I just didn't have the simplification yet in my head. So yeah, you can use 25.
Okay, sir.
Yeah. As long as it reduces the number so that it makes it easy for you to do the calculation. So the other one is about square root of 0.16 minus 0.4 then squared divided by the cube root of 0.008 minus 0.023. So here, you know that the square root of 0.0, the square root of 16 is 4. So meaning the square root of 0.16 is 4. Okay. It will be 0.4 because the square root of 16 is 4. So the square root of 0.16 is 0.4. So on top we are going to have 0.4. Yes, we're going to have 0.4 minus 0.4 squared. And then also we know that here we have a cube root. Okay, we have a cube root of 0.008, which is 8 over 1000. So the cube root of 8 is 2. Cube root of 8 is 2. And then the cube root of 1000 is 10. So the cube root of 0.008 actually is 0.2. So here we have 0.2 cubed. So what we have here is 0.4 minus 0.4 squared over 0.2 minus 0.2 cubed. So now we can simplify here. 0.4 is common, so we have 0.4. And then we have 1 minus 0.4. Here also 0.2 is common. Then we have 1 minus 0.2 squared. And if you can multiply 0.2 by 0.2, you are going to get 0.4. Just try. 0.2 by 0.2, this is 4. And this is 0. And then this is 0. So 0.4. So 0.2 squared is 0.4. So you have 0.4, 1 minus 0.4 over 0.2, 1 minus 0.4. So 0.4 is going to cancel. So what you get is 0.4 over 0.2. This is the same as 4 over 10 divided by 2 over 10. This is the same as 4 over 10 multiplied by 10 over 2. And then this is just 2. Okay, so the answer should be A. So what I did, what I've done is, I don't know if you can see, I write big things. Yeah. I've written all the steps there. Okay. It's straightforward. Unless you have a question, this is just about simplifications, okay? I'm sure some of you already did this, like you answered already the correct answer. So these are the steps. This is what I did. Okay, that's straightforward, right? So if there's no question, we can go to the next question. And by the way, if you answered before, you can say, okay, that's what I found. Yes. Okay. So now the other question is, question 4 is a little bit of you just have to do some manipulation. I mean, it's also simple. It's like you have a system of equation with 3 unknowns, but actually these are 2 unknowns. Okay, like a system system of linear equations. So you're okay with question 3, right? So for question 4, we have 2x plus y minus z equals 12, and 3x plus y minus z equals minus 4. And then what is x? That's what they're asking. What is x? So the easiest thing, you know, is elimination. Okay, we are going to eliminate z and y. How do we eliminate? So we are going to multiply either of the equation. If we choose, we can use the bottom equation or the equation above. So we eliminate by multiplying with a negative. So we have 2x plus y minus z equals 12. Then if we multiply minus with the bottom equation, so we have minus 3x minus y plus z equals 4. So what do we do now? We just add this up. So when we add minus z plus z is going to be 0. Then y plus minus y, this is also going to be 0. So we have minus x equals, what is this? It's 16. So x is minus 16. Okay, which is B. Yes, x is minus 16, which should be B. And that should be the answer. Yes, that should be the answer. Yes, that's B. Now, I mean, just a minute. Now 5. No. I think for, for question 3. For question 3, I think they made a bit of a mistake. I mean, those people. I mean, our answer is correct. What I found there is not, it's not correct, but yeah. So you just have to follow the steps that I've that I'm trying to follow. So let's see question 5. Question 5 is about integers. So we have k, n. These are both positive integers. In other words, these are natural numbers. They are positive integers. So we have k, n, members of plus z. They are positive integers. And then what we have, n squared, n minus 2, n factorial, over n plus 1 factorial equals 7 over k. And then the question is, what is k? Question is, what is k? So here, here you just need to know the formula for factorials. Okay. So n factorial is the same as n multiplied by n minus 1 multiplied by n minus 2 multiply by n minus 3, and you go up to where the numbers end, okay, until 1. So you're going to be reducing by 1. So you have n times n minus 1, then times n minus 2 times n minus 3, then until you come to 1, okay, until you reach 1. So n minus 2 factorial is the same as n minus 2 times n minus 2. Then you subtract 1 to be n minus 3, subtract 1 n minus 4 until you go to 1. Similarly, n plus 1 factorial is the same as n plus 1 times n plus 1 minus 1, which is n, times n minus 1 times n minus 2 factorial, okay, because it's going to continue to until it reaches 1. So what we do is you write n squared. What is n squared minus n minus 2 factorial over, in place of n plus 1 factorial, you are going to write n plus 1 times n minus 1 times n minus 2 factorial. And then this is equal to 7 over k. This is equal to 7 over k. So n minus 2 factorial and n minus 2 is going to cancel. So we have n squared over n times n plus 1 times n minus 1 equals 7 over k. And then what we have is, we have difference of squares, n plus 1 and n minus 1. Difference of squares, when you have a squared minus b squared, these are two squares, the same as a plus b and a minus b. So what we have here is n just a minute, n squared over n times n squared minus 1, which is 7 over k. And then n into n plus n into n squared, you have n over n squared minus 1 equals 7 over k. So you have this expression. So if you have this fraction, n over n squared minus 1 and 7 over k. So for this to be true, it means n is equal to 7 and k is equal to n squared minus 1. So since n is equal to 7 and k is equal to n squared minus 1, k equals n squared is 7 squared minus 1, which is 49 minus 1. So the answer is k is just a minute. Yeah, k is 48. K is 48. So this is what I'm trying to do. This is what I'm trying to do. Okay. I don't know if you can see. You can see. You can see it. I don't know if you can see. I said n squared times n minus 2 over n plus 1 a factorial equals 7 over k. So I have defined what n plus 1 factorial is. I defined it as, I defined first of all n factorial. N factorial is you multiply a number with, you multiply numbers in descending orders. Like if you say 5 factorial, it means you're going to have 5 times 4 times 3 times 2 times 1. You are multiplying in descending orders. Okay, the simple thing also, like let's say 6 factorial. So you have 6 times 5 times 4 times 3 times 2 times 1. So you are multiplying in descending order. So even for n factorial, you have n times n minus 1 times n minus 2 times n minus 3 until you reach 1. So I defined n factorial. So I also defined n plus 1 factorial. Okay, so I expanded it until I reached n minus 2 factorial, such that n minus 2 factorial cancels, okay, with the one on the what can I say, one on the numerator. So n minus 2 factorial cancels n minus 2 on the denominator. So this is what I did, and I've done simplification, and then there you have 7 over k equals n over n squared minus 1. These two fractions can only be true if n is equal to 7. So if n is equal to 7, then k is equal to n squared minus, what has happened? It has paused. Is it time over? Yeah, the video is paused. Okay, yeah, I started it. So yeah, so this is what I did, just simplification. Okay, okay, this is the paper. You mean for question 4? Okay.
We don't see the
For
video.
For question 4, it's here. Did you see it?
We don't see.
For question 4. Can you see it?
So maybe I think you can do what was the system that was saying, using the camera and writing on a piece of paper and then see the answer.
Yes.
You look like this and not for.
Yes.
Is it trying to work like this, or you prefer that he has like a board where you can write things like this? Yeah. So, things like this is
Yeah.
are they seeing what they are doing?
No, man, it's not. It's not. It's a bit difficult.
Yeah. I think it's better. Okay, she said you are very.
Yeah, I just showed him. Yeah.
Do you think that continue like this, or we try to find a good solution for this thing? Because if it goes like this, you think get what he said.
Okay.
Yes, maybe on Thursday. Maybe a camera that you can show directly.
Camera or tablet, yes.
Camera.
Yes. No. I mean, how my supervisor works is, you know, you have a camera right here. So I don't know how to connect. There's a camera so that when I'm writing, it's projecting. Yeah. So when I'm writing, yeah, it's projected to the screen. Yeah. Yeah, and yeah. They are mute.
Jessica, are you there?
Evet, I'm there.
Okay. Is it look like this? Or it's better to keep on this?
I don't understand you very well.
Okay. Est-ce que quand il produit, il travaille comme ça sur le papier présente, est-ce que c'est mieux ou bien c'est mieux qu'il le fasse sur un tablet comme les autres?
Moi, ça ne me dérange pas parce que c'est juste une révision que je suis
Ah,
en
c'est
train
une
de
révision,
faire.
n'est-ce pas? Oui. Ah oui, oui, vous avez expliqué les trucs au début pour les francophones, n'est-ce pas?
Oui.
And the Anglophone, is it okay to work like this? Should I leave it going or should we stop and look for a better solution? Dalfan and Zena. No, according to me.
Yeah, that's
Ok.
better.
Donc, je pense qu'on va arrêter comme ça. Il a fait quand même quelques exercices. Et ce qui est bien compris pour ceux qui avaient déjà fait ça. Pour les anglophones, I think it's better to have a tabloid, like maybe a camera, so that you can see directly what is showing to you on the paper or whatever. Right? So I will stop the session. I'm really sorry for this it's a technical problem, but we will find a good solution for the next Thursday. Are you available on Thursday? Thursday from 6 to from 8 to 10, because here in Turkey you come only 6 to 2 hours to go with these questions.
I think in the evening, yes.
In the evening. Yes,
Because-
talking about PM, not AM.
Hmm.
We cannot have a class.
Yeah, I think in the evening, because let's say Thursday, probably evening, yeah.
Thank you.
Yeah.
Thank you very much.
I have problem. I didn't see the end of the last question.
What's that?
The end.
At the end of the last question.
Yes.
It's 48.
Okay. It's okay.
Have you seen how it's going? I mean the procedure.
Yes.
Okay.
Thank you.
Yes, you can do this. It's simple. I mean.
So see you.
Okay.